what an identity is, okay? And we talked about the fact that you can rearrange things in an equation or an identity, and it still holds true. Okay, so down here in number 1, they wanted you to complete this table by picking any numbers that you wanted to fill it in. So I just did, there's one already filled in as an example for you, but then I wanted to fill in another one showing the work so you knew exactly what it was you were supposed to be doing. So you can see if I randomly chose 4 and 2 as my X and Y, if I plug in a 4 for X and a 2 for Y into this X squared minus Y squared, I get 16 minus 4, which is 12. And if I plug it in here, I get 4 plus 2 and 4 minus 2. That's 6 and 2. 6 times 2 is 12. So those came out the same. All of y'all should probably be different if you were picking different values, okay? But what should happen with both of the last 2 columns? All of them should be the same. Both columns should, like how this was 5 and 5, and we just got 12 and 12. So your answer for A is that they should come out the same. They should be equal, okay? Because this identity is true no matter what you input. Does that make sense? So that's just reiterating that an identity is true no matter the input. Here is a review of our functions, our trig functions that we have found some basic identities for in previous lessons. We know which functions are reciprocals of each other. We know that sine and cosecant are reciprocals. So sine is 1 over cosecant, which means cosecant is 1 over sine. That's literally just multiplying the cosecant over and then dividing the sine over. Again, it's just rearranging. If this one's true always, then this one's true always. Okay, so hopefully you were able to fill out the reciprocal identities. Then the quotient identities, we have talked about these. I don't know that we called them identities before, but your quotient identities are one. Quotient means divide. So when you're dividing 2 trig functions, that's your the quotient identity. So we know that tangent is sine divided by cosine, which means cotangent is cosine divided by sine because it's the reciprocal. You flip the fraction, flip the ratio. Everybody okay up to that point? All right. Now on 3, then they wanted you using Pythagorean theorem and some the basic trig knowledge, trig ratios, and making some substitutions to derive our Pythagorean identity. Okay, so if I have a triangle where the legs are A and B, the hypotenuse is C, okay, what is the equation? What is Pythagorean theorem in terms of A, B, and C here? A squared plus B squared equals C squared. That's it. It is the Pythagorean theorem. If I had called these X, Y, and R, I could say X squared plus Y squared equals R squared, right? Okay, so this one just happens to be just A, B, and C, so it straight up is the Pythagorean theorem. Now, in this image, in this graphic that they give us, what is the ratio for cosine of theta? Here's theta, the central angle here. Using they've labeled the sides A, B, and C. What is the ratio for cosine? Good, because it is the adjacent to the hypotenuse or the X to the R. What is sine's ratio? Which is opposite over hypotenuse or Y over R. Everybody on the same page with that? Now here's where it got a little tricky for some. This part D wants you to use, and I know yours printed without much space here, but I think you have plenty of space up here to do the work. Use substitution and simplification to combine these 3 pieces of information to come up with an equation that's only in terms of theta. So I want to get rid of A and B and C. I don't want to have A, B, and C in my equation. The only variable I want to have is theta. So do you remember back in, I don't know if you did this at all in Algebra 1, but definitely in Algebra 2, systems of equations. We had multiple equations and you used substitution to replace things and eliminate variables. Y'all remember doing that? That's what they're asking us to do here. They want us to make some substitutions in here. They don't want A, B, and C. They want theta. So I could solve this for A, couldn't I? How could I get A by itself? Yeah, I would just multiply that C over to the other side. So this would be A equals C times cosine of theta. Or you could have written cosine of theta times C, it doesn't matter which order, okay? But now I can make a substitution for A. I can replace A with what it's equivalent to, right? And I can do the same thing for B here. If I solve for B, what is that? C times sine of theta. Okay, I just multiply the C over to the other side. That's what I was trying to get you the connection to what we were doing at the beginning of class when I was saying I can rearrange things and it's still true. So I can move this C over to the other side and this equation is still true. So then I can make the substitution for B. This is the equivalent of B. So then this would become C times cosine of theta squared. And make the substitution for B, it would become C times sine of theta squared equals C squared. So that's the substitution portion. I'll go ahead and highlight here what I substituted. Now comes the simplification. We use substitution, now we want to simplify. Okay, if I am squaring something, there's parentheses squared. I'm squaring everything inside, aren't I? So this is going to be C squared times cosine squared theta. This will be C squared times sine squared theta. Now, what do you notice all of the terms in this equation have? So can I simplify that? If I were to try and divide that C squared over, I would divide every term by that, right? This is what I was trying to review with you at the beginning of class. This does not become 0. It doesn't go away, right? It becomes a 1. So all of those C squared over C squareds reduce to a 1. So we end up with cosine squared plus sine squared equals 1. Now, it can be written that way, and that's totally fine. But I can also rearrange it, can't I? The most common way you're going to see this identity written is with sine squared written first, and then cosine squared. But like I said, it doesn't matter if it's cosine plus sine equals 1, cosine squared plus sine squared equals 1, or sine squared plus cosine squared equals 1. They're both true, right? So this is the first Pythagorean identity. That's what I wanted y'all to derive from Pythagorean theorem and our trig ratios. When we put them together, this is what we come up with. Does that part make sense? And this is going to always be true, no matter what theta is, what angle measure it is. If I plug it in, that's going to come out to 1. So that's what number 4 was having you check. They're like, okay, pick an angle from each quadrant and check it. Now, I'm not going to go through and do all of this with you, and you could do some in degrees and some in radians. But if I were to plug in 30 degrees, first of all, before I jump into that, there's a note at the bottom here that's very important. This sine squared theta is the same as sine theta squared with the sine theta in parentheses. Now, what this is not the same as is sine theta squared like this. That is not the same thing. That is not an okay to write it. way to write it, because that is saying the angle is squared and then we take sine. With this notation, we find sine of theta and then square it. So sine of 30 degrees is what? What's sine of 30 degrees? 1/2. And what's 1/2 squared? Okay, what's cosine at 30 degrees? Square root of 3/2. And what if I square it? I'll do that off to the side. Square root of 3/2. When you square a fraction, you square the top and the bottom. So what does that become? Now, what's 1/4 plus 3/4? So that does indeed work, right? Sine squared plus cosine squared is 1. Now, I'm not going to go through all of these, but you should have tried an angle from each quadrant and shown that it was accurate. Now, on the back, the second page here, I want you to add, or on the back of the second page, I want you to add these 3 problems that say solve. Just write those down. If you have a chance to try and finish going through this tonight, I'd like you to, and then to try it. If you don't, it's okay. I'm going to make a second video finishing out going over the second part of this, and I'll go over those check for understandings. So I'd like you to check those tomorrow and make sure that that makes sense, because these examples that we're adding here, this is combining these Pythagorean identities we're deriving with what we just tested on, solving trig equations. Okay? All right, y'all have a great day. You can start on that semester review.